Good afternoon, everyone. Dear authors and innovative guests, welcome to Technical Session 4D. I'm Jay Lalwani, moderator for this session. On behalf of Global Knowledge Search Foundation and Knowledge Chamber of Commerce and Industry, it is my great pleasure to welcome you to the 7th International Conference on ICT for Sustainable Development through Zoom. I hope you will enjoy knowledgeable and interactive sessions throughout the day. Uh, there is a special note for the presenter. You will be given 8 minutes for the presentation and 2 minutes for question and answer. On 7 minutes, I will raise a gentle reminder. There is another request that you all stay connected with us till closing remarks. If you have any query or update, you can write it to me in the chat box. Just before we get started, I would like to introduce you to chair for this session, Professor Jitendra Bhatia. Professor Jitendra Bhatia is an associate professor with computer Nirma University, Ahmedabad, India, and he has more than 16 years of teaching experience at undergraduate and postgraduate level. He has published, presented a number of papers at reputed international and national level journals and conferences. His main research interests include protocol design for intelligent transportation system, software-defined networking, vehicular problem networks, and cloud computing. Welcome, sir.
Thank you. Thank you.
Sir, please start with the papers.
So very first is, I think, Sonia Nivik, I think.
Good afternoon, sir. Am I audible, sir?
Yeah.
Is the screen is visible, sir?
Yes, you can share.
Yes.
Start.
Good afternoon, everyone. I am Sonia Nivik from MCA department and from Nitya Meenakshi Institute of Technology. And this is the abstraction. In this research paper, a complete conversation on the development in ubiquitous computing and the related to the technology applications has been done, and the comparison between the ubiquitous computing and IoT has been done, as they have the same kind of technology that can make to build the smart technology or devices that can make the world better. In the introduction part, let's first get to know that what is a computer. A computer is a device which take an input and process the data as per the instruction and produce the output. So in ubiquitous computing, it is also known as pervasive computing, as ubiquitous means present everywhere and computing means computer. So ubiquitous computing is just like we used to make it smart technology that make the world more efficient to use it in convenient way. We uses three most technology to build up the ubiquitous computing is microelectronic technology, digital communication technology, and the internet standardization. We can just like give the example of the ubiquitous computing has the smart home concept is the example of ubiquitous computing. Like we can control many multiple devices with our mobile because they are all smart devices connected to each other, and mostly they have all these components which are mainly used in the ubiquitous computing, that are the sensor processes and which will give the output of it. It has three layers. The first layer in the administration layer, it will create the it will create the communication between the devices and the users. And in the second layer, it will create an atmosphere using the administration layer, and it will refer to the supportive and properties of the ubiquitous layer. Then this is the structural layout of the how the ubiquitous computing work. These are the sensors, embedded computing, and low cost just like connectivity, how this uses with the IoT to make the smart materials and design with the application of it, and the output will be just like how the ubiquitous computing made an application that will be usable. The analysis of it is here, just like we have uses the ubiquitous computing to know the automated devices and create a environment to connect information between the users and the devices. it creates the devices which are agile and easy to communicate with the devices to send data between the users. It focused basically on the numerous atmosphere depending on the devices and the wireless equipment to the progressive microchip technology. And in this we uses mostly IoT also for hooking up the things between the devices using sensors to make the devices more real-time data. In this, we made the comparison between the IoT and ubiquitous computing, as ubiquitous computing is human to machine interaction and IoT basically falls on the machine to machine interaction. And ubiquitous computing is achieved with the mobile devices or electronic devices, and mostly in this both ubiquitous computing and IoT, mostly sensors play an important role for making the devices work. And the IoT is just like subclass of this ubiquitous computing that help the ubiquitous computing to build the devices. And it is an interrelated computing devices that identify the ability of transferring the data over network with human intervention. In conclusion, in this, we have just like give an idea of how ubiquitous computing has a machinery to build it, and we have go through that how ubiquitous computing technology application and other sensor devices will give the privacy and control over the machine devices that will make the user to use it more compatibility, and demonstrate how the technology have been using developing more device and will make human life easier and comfortable to live in upcoming future. And these are the references I have taken for my survey. Thank you.
Sonia, what are the challenges in ubiquitous computing? What are the challenges and their limitations?
Sir, challenges is just like it will be just like connecting with the sensor. If the most important part is just like sensor, it will be using sensor for it. If any disturbance of any limitation will occur in the sensor, then probably the device will not be working, because sensor is the most important key in making the development of ubiquitous keys.
Okay, and did you analyze, Miss, have you explored about the next generation networking? What is the role of this IoT and ubiquitous computing in next generation networking?
Yes, sir. The IoT, as we can know, it is just like most upcoming application in future we are using nowadays. So just like we are using IoT, is just like in every future devices that we can use for agriculture, for just like more another technology and all that. So ubiquitous computing, and with the users of IoT, we can make such devices that will make more human life easier, and it will just like easy to connect with Aura, just like human appliances, and it will make more smart world.
Okay. Okay, fine. Thank you.
Thank you, sir.
You have to be online up to end of the session. You have
Yeah,
to...
yeah, sir.
Okay, so next paper presenter, content-centric prediction model for early autism spectrum disorder screening in children.
Yes, sir. Good afternoon, sir.
Okay, okay, Anita. Yes, you can now.
I'm just sharing the screen, sir.
Yeah, sure.
Is it visible, sir?
Yet not. Not yet.
Yes. On a content-centric prediction model for early autism spectrum disorder screening in the children under the guidance of Deepti Patil ma'am. This will be just the flow of the presentation.
Little bit problem, otherwise fine.
Yes, sir. I'll just complete it first.
Okay, done.
This will be just an outline for my presentation. So let us start with the introduction. So nowadays, autism, the autism spectrum disorder, this is being a severe neurodevelopmental disorder which is impacting onto the communication and the interaction skills of the children. Basically, these symptoms have been seen in the initial stages of the lifetime. So what type of symptoms do these children have? It is about a recurring behavior. They just spend maximum of their time in doing the recurring behavior. They do have the absence of the enthusiasm. Similarly, be stubborn about the routine to be followed. It's very difficult for parents to change their routine. Like it can be a diet or it can be a specific routine they want to do. So in traditional way, you have the method for ASD detection. So it is done by just in the behavioral inspection. And at the same time, we can have the parents for that. So just by observing symptoms, we can make some observation and we can diagnose it. So what is the motivation we this work? Though we know that reasons for ASD are there in the genetics or might be in development, environmental factors. Still, the type of life they experience, it can be improved or enhanced just by having diagnosing and treating them. It means providing them some suitable treatment at the early stages. So in present time, we do have clinical tests for the ASD diagnosis, but they are time consuming and costly as well. So what is the proposed work here? We just want to implement a content-centric prediction model, which will be helping us in order to make screening of this ASD in the children at the early ages. And definitely it will be helping them in order to have the healthy life cycle, healthy life like the normal people. This is just a proposed system architecture. The data set has been selected from the UCI repository, which is freely available. Some processing will be doing on the data set, and features selection will be the next step. The 11 features are selected from the data set. Then it's part next is a phase for the model construction. In model construction, different learning have been selected for the classification purpose. And then we'll be just predicting upon whether the patient, whether that particular child is having the autism disorder present or not. And finally, it will end up with the performance evaluation, and later on we can generate some personalized recommendations to them, which will be helping them for the healthy life cycle. This is just a description of which is used in the implementation. This ASD data set, it has total 20 fields, in which first 10 fields are a behavioral description, in which one question has been asked, and that will be in the form of the 0 1. Whereas the next 10 attributes or the variables from the data set, they are basically the demographic, the country where they belong. So this is just a generalized general description. So in implementation, I have used 3 different data sets. The 3 different CSV types in the data set were available based on the age group. So adult with the 704 instances, adolescent with the 104 instances, and the child data set with 92 instances. Different machine learning models. These are the following models which were implemented on this particular data set for the prediction of logistic regression, which is the statistical analysis method, which is used to predict the binary outcome. Then the decision tree, we just construct the decision tree based on the selecting criteria. Neighbors, it mainly works on the probability of the nearest neighbor and the random for itself. The performance of the conceptual prediction model, it has been actually evaluated in terms of some performance metrics like precision, which mainly tells us about, or rather it just measures the relevance of the model prediction, whereas the second recall, which is just tell us about, or rather we call it as a true positive rate or the sensitivity, and it mainly tells us about the proportion of correctly classified sample, and the F1 score, which is just calculated as the harmonic of the precision and the recall. So these are some of which are by using the rapid manner data mining open source tool for 5 different machine learning algorithms for accuracy and the error graph. And these are some of the values which I have received or the result which are generated by the implementation. So this is just a which is seen as one of the major increasing neurological disorder in the toddlers in early ages itself. Doing the diagnosis of it at the early stage and suggesting them a suitable treatment, it can be a challenging work, because many times it happens that parent notice or rather the ASD get noticed in their children at very late, or rather if it is done at the early stages, it will be easier for doctors and parents to handle those children. And as the machine learning is doing an excellent job in performing or rather implementation in different domains. So in the healthcare as well, it has shown very accurate results. So in this proposed work, the machine learning algorithms have been used on this data set and its performance has been evaluated of the evaluation metrics. So we'll just try to compare the values, the decision trees, the models. So in future, some deep learning algorithms can be incorporated in this so that we'll be able to work with the massive amount of data in order to fasten this particular diagnosis process. And similarly, some personalized recommendations can be given to the patient, like we can suggest the doctor or any treatment or specific diet to the patient so that they'll able to live the healthy life cycle. These are some of the references which I have used. Thank you.
Have you tried your model on another data set also? If you have, I don't know whether you have or not set data set.
On other data sets. So this data set I have used. Along with that, I got one more data set, which is the toddler data set. But again, in that I got same data fields. The variables were exactly same. For the autism, sir, other data sets are available, which are actually the image data sets, in which the pictures of the patients are there, and based on their facial expression, some detection can be done. That is possible in other ways, but that we in an image processing domain.
So what was the ratio of testing and training?
So I had selected 70%. I had taken 70% of the data for the training, and 30% was selected for the testing purpose.
Okay. Thank you.
Okay. Thank you, sir.
Yeah. You have to stick to this up to end of the session, please.
Yes, sir.
All
yes.
of it.
Yeah. Yes, sure.
Hello.
Next is missing link prediction in the social network using GCN.
Okay. Hello. I'm audible.
Yeah.
Oh, I can't share the screen. It is showing you can't start sharing while other participants are sharing.
You can share now.
Oh, okay. Okay, my screen is visible, I guess. Hello.
Yes.
Fine.
Okay, so good afternoon, everyone. My topic for my project is missing link prediction in social network using graph convolution network. So these are the content which I will be explaining in the further slides: introduction, research gap, solution approach, proposed method, validation, and summary. Okay, so starting with the introduction basic, what is link prediction? Link prediction is a problem of finding missing link or a link that are more likely to appear in nature or future from a set of non-existing link. The main objective of link prediction is to identify the pair of nodes that will either form a link or not in future. The best example of link prediction is like content recommendation, predicting friendship amongst the user. Like in social networking site, we can predict we can predict in Instagram, WhatsApp, Twitter, not WhatsApp, Facebook, Twitter. So link prediction is a problem of finding missing link, future link, or false link in a network. Here you can see we are considering social network as a graph. So here you can see in a graph we have 5 nodes A, B, C, D, E, and our main objective is to find a link whether E and C will form a link or not in future. This is about the link prediction. Application of link prediction, where we can use link prediction. General application is for recommending friends to a particular user. We can use in for identifying the terrorist attack based on predicting the hidden link in a social network group formed by a terrorist. We can use it in bioinformatics for predicting interaction between the protein, and it can be even used in suggesting interaction or collaboration between the employees in an organization. Now, while talking about the research graph, a majority of algorithms were based on the information of either node or link. Majority of proposed method is suffering from the information diffusion problem. So what is information diffusion problem? I will explain. So in general, in layman language, information diffusion occurs when a user in a network try to retransmit its information which he received from its neighbor. For example, we can consider 3 users in any social networking site XYZ. where X is having a link with Y is having a link with Z, and X and Z is not having link. But if X user shares some information, then there will be a possibility then X and Y can form a link. This is about the information diffusion, and majority of method were having time complexity issue. So the solution which we are providing is the information diffusion problem we can solve using partition and combination of network based on label propagation. And we are using graph convolution network since it is a semi-supervised method. Okay, so while talking about the dataset, the dataset which I have used is a Facebook dataset. It has a node of 40,039 and edges about 88,234. So this is the visualization of the Facebook dataset with 747 nodes and 30,025 edges. This is the Kamada Kawai layout of Facebook dataset. So now the method which we proposed, our method generally consists of two steps, like I said in general, partition and combination. So and community detection algorithm is used to divide network into a cluster, and novel algorithm is used to detect the unvisited link based on the likelihood score. And graph convolution network is used since it is semi-supervised method. It can be used for unlabeled node to improve the accuracy. So this is the workflow. We are using Facebook dataset. Then we are doing partition based on community greedy algorithm. Then we are doing label propagation. We are assigning label to obtain cluster. Then we are doing combination based on the threshold value, and then we are applying JSON to improve the accuracy. So now in partition, firstly, a community detection algorithm is used to divide network into a different partition or a cluster. So initially, every node will be having a label from 1 to n, where n will be the number of nodes in a network. Then the main principle of label propagation is that nodes should belong to a community that consists maximum number of influence neighbor. This is about the partition. And in combination, in this phase, communities identify in the partition phase and re-examine and merge based on the stability. So we are using detachability index theta. Based on that, we are merging. If the threshold is less than theta, then we are merging with more stable communities. Like we are combining it in combination phase. And the proposed method is using graph convolution network. So the reason why we are using graph convolution network, basically it can employ in classification, segmentation, and clustering tasks. Since we are doing clustering, so main objective of GCN is for doing clustering, and even it is semi-supervised method, so it can be used for unlabeled methods, unlabeled things only. That's why we are using GCN. So the main idea of GCN is basically we targeted the low degree nodes with larger weight, and we are passing the resulting feature through a neural network for training. In GCN, there are two methods basically. Either we can change layer by layer, or we can change the activation function. In our case, we are changing layer by layer. So the result which we got is, in our case, when we stack from 32 till 32 layer, the ROC and AP values are improved. So these are the few results tested with different dataset. Like Facebook dataset, we got around accuracy of 90% with 747 nodes and 30,025 edges. In Karate Club, 32 nodes and 78 edges, we got 89% accuracy. And Dolphin dataset, 62 nodes and 159 edges, we got 90% accuracy. So this is the graph of accuracy. This is the confusion matrix which we got as part of result. And for validation, we used NumPy, SkyPy, and precision recall curve, and average precision and AUC values. Summary. So in last, I can conclude that in this method is very useful for solving information diffusion problem, and GCN we used for semi-supervised classification, and time complexity can be reduced using this technique. And using GCN, we can identify the densely linked cluster of nodes. So these are the references. Thank you.
Samil, can we, instead of GCN, if we go for GNN, then what will happen? Will it be feasible for applying GNN?
GNN, since it is a graph, so I used the graph convolution network. I don't have much more idea about GNN, whether it will be feasible or not.
Okay. Actually, GCN does not share the weight between the.
Yeah.
Okay.
Hmm.
Fine. Okay.
Okay, thank you.
Next is two-phase mitotic detection using DL technique. Anjali.
Yes, sir.
Yeah, please share your presentation.
Okay. Yeah. Are you able to see my screen?
Yeah, fine.
Good afternoon, all. My name is Anjali Venugopal, and I am from Amrita School of Engineering. The title of my project is Two-Phase Mitotic Detection Using Deep Learning Techniques. And I am doing this under the guidance of Ms. Lekha S. Nair, Assistant Professor, Amrita School of Engineering. These are the overview that we are going to discuss today. According to the latest studies by World Health Organization, breast cancer is one of the most frequent types of cancer that adult females suffer worldwide. Thus, early diagnosis and detection of breast cancer is very important. So how breast cancer occurs is like when the cells in the breast start to grow out of proportion and it starts to invade the neighboring tissues or it spread throughout the human body. And there are several imaging methods like mammography, ultrasound, etc. for the diagnosis of breast cancer. But pathological breast imagery is in high demand because it is considered as the golden standard for the diagnosis of breast cancer. So actually histopathology is the microscopic examination of tissue in order to study the manifestation of diseases. So mitosis is a process where the cells divides into two daughter cells. And cancer occurs when these division occurs more frequently and it starts to invert the neighboring tissues. So one of the important metrics that pathologists use to detect the aggressiveness of the tumor is the mitotic count. So here are a few examples of mitotic nuclear regions and non-mitotic nuclear regions. It is visible from the figure that there are variations in the shape and size of the mitotic and non-mitotic nuclear regions. So the proposed method, actually the data set we are using here is mitose TPR14 data set, and the slides are changed with standard hematoxylin and auxin dyes. So in the pre-processing stage, we are having 541 images and the data set is of the size 1539 by 1376 pixels. So after that, the labeling of the data set is done in the YOLO format. And after that, the next part is like the color normalization. That is the standardization and stain normalization is done here. For that, we are using stain tools library and Bahatane method is used for that. After that, the augmentation process is done, which is carried out actually we are doing the horizontal and vertical flipping, rotation, bounding box flipping, and also we are resizing the images into a standard format of 1280 by 1280 pixels. The next phase, that is the detection model training phase. Actually, ours is like a two-phase detection method. Like for detection, we are using YOLO V5, and for classification, we are using EfficientNet model. So training of YOLO V5 networks is carried out in 120 epochs, and the output image shows the detected suspicious nuclear regions. That is, an initial screening is carried out in the detection model itself. That is, we are not considering the ones that can be easily identified as non-mitotic nuclear regions. We are only considering the ones that is expected to be a mitotic nuclear region. And the next phase, that is the classification training phase. Actually, here we are considering the complete histopathology images in which there are several number of mitotic and non-mitotic nuclear regions. So first, we are extracting the mitotic nuclear regions, which is detected from the detection phase, and we are getting the non-mitotic and mitotic nuclear regions. And in the training set of the YOLO data set, and we split it into the training and validation set, with the mitotic count as 1983 and non-mitotic count as 3207 images, which is of the size 224 by 224 pixels. And then the training of EfficientNet is carried out, and it outputs with the predicted label. So in the inference stage, first we load the test images and we detected the nuclear region, that is suspicious nuclear regions, using YOLO. Then after that, we are extracted the images into the nuclear regions only with the size of 224 by 224 pixels, and it is given to the classification layer. And then the classification layer detects the mitotic and non-mitotic nuclear regions, and it maps it with the test image, and it gives a confidence value also. So as I said, this is a two-phase algorithm involving the detection and classification. So as depicted in the above figure, we are doing stain normalization here. For that, we are using Vahadane method. And for the detection, we are using YOLO v5 model. So ULOOKULI1's version 5, it is a novel convolutional neural network that detects the objects in real time with greater accuracy. And so in the inference mode, the network firstly normalizes the images and it is fed to the detection layer. And the detection layer extracts the suspicious nuclear regions with its corresponding bounding box value. And then it is given to the classification layer, which is EfficientNet. So EfficientNet achieves a better performance with lower number of parameters. And by decreasing the parameters, we actually get a benefits like a smaller model size and making them fit into the memory easier, etc. And so for classification, we are using pre-trained customized EfficientNet with excluding the top layer and adding a dense layer of 2 neurons for the classification of mitotic nuclei. Then the classification layer classifies whether an image is mitotic or not, and finally draws the bounding box on the input test images. So the first phase, that is the dataset pre-processing phase. So here we are using Vahadane method for the stain normalization. So in Vahadane method, it estimates the sparse and non-negative stain density map from the color images and then combines the stain density maps of the source image with the color based on the target image. And after the color normalization, we are resizing the image to the standard format. And then we are creating the bounding box of each images in the YOLO format. And in the classification layer, that is the EfficientNet classification layer, the mitotic and non-mitotic nuclear images are extracted, and which is resized to a size of 224 by 224 pixels. This is the output. This is the output of the pre-processing state. Then the YOLO v5 detection. In the detection, the dataset is labeled as both mitotic and non-mitotic nuclei, and it is transformed to the YOLO format. And as I said, the images is of the size 1280 by 1080 pixels. And for training, the YOLO v5S version network, which is used with the pre-trained weights from the COCO dataset as initial weights. And the training is carried out using stochastic gradient descent as the optimizer function, which is an optimization algorithm to find the model parameters that correspond to the best fit between the predicted and actual outputs. And in the inference stage, the detected suspicious images are cropped along with the bounding box coordinates are transferred to the classification layer. So this is the output of the nuclear detection phase. The suspicious nuclear regions are detected in this phase. So in the classification phase, as I said, we are using EfficientNet V2S model. And first what we are doing is, like, from the complete histopathology test image, we are cropping the mitotic and non-mitotic images, and we are saving it to the folder. And then the augmentation process is carried out with Keras as the image data generator implementation. And the augmentation operations are done like horizontal flipping, vertical flipping, rotation, and shifting operations, etc. And it is trained with Adam as the optimizer and the categorical cross entropy as the loss function. And already I mentioned, like, the top layer is removed and global average pooling layer and dropout layer is added. And in the final inference stage, the detected class along with the bounding box are mapped to the input hold slide image. In the results, this is the nuclear detection results, the precision curve, recall curve, precision recall curve, and the F1 curve. So this is the output of the nuclear detection results. So this is the actual label and the predicted label with the confidence value. This is the output of the nuclear classification results. The first one is the accuracy curve for classification model. And the best model, we are getting an accuracy of 0.972. And second one, that is the loss curve for classification model. And for the best model, we are getting a loss of 0.092. This is the normalized confusion matrix. And this is the final output, like the mitosis and non-mitosis with the confidence. So this is the performance analysis of the model on the mitosatifia 14 dataset, that the mean average precision at 0.5, confidence and precision, recall, and F1 score, and accuracy for the classification model, that is 0.971. So this model, it's a deep learning model that predicts whether the nuclei is mitotic or non-mitotic. And this is a two-phase algorithm with detection and detection network and the classification network. For detection, we are using YOLO v5, and for classification, we are using efficient net model. And in the final phase, the images are relabeled from nuclei to corresponding mitotic or non-mitotic nuclei. And the results show that the proposed model is efficient for the prediction of mitotic or non-mitotic nuclei images in histopathology images. Thank you. That's it.
What was the size of your data set?
Actually, the size of the data set was about 980 images, something. Used only 541 images.
Attributes, number of attributes? Features, I'm asking features. If you extract the image from image.
Pardon, sir, can you repeat?
See, you have image data set, right?
Yes, yes.
So which kind of features are available from that? Once you are taking the image, then are you identifying some features from that? And based on that, you are running your model?
Not actually. We are directly giving to the training phase of the YOLO v5.
Directly given to YOLO v5?
Yes.
Okay. Have you tried the same thing apart from YOLO v5?
Yes, a mid-hoc data set also.
Okay. Okay, fine. Nice work. Okay, fine.
Okay, sir. Thank you.
Next is information and communication technology acceptance among police personnel in Rajasthan. Umesh Mishra. Umesh, you are not audible to us.
Hello.
Yeah.
Umesh, I think he's technical issue in voice.
Yes. Mr. Umesh, you can sort out your problem. By that time, we can start with another participant.
Yes, yes.
Yeah, okay. Next is PortFast, extractive audio summarization by Atharva Deshpande.
Hello. Hi, sir. Am I audible?
Yeah.
So I'll just start sharing my screen. Is my screen visible?
Yes, yes. Continue.
So, good afternoon, everyone. Myself, Atharva Deshpande. I am from Pune Vidyarthi Griyas College of Engineering and Technology, Pune. And I, along with my teammates, Shruti Yadav and Meher Gupta, we have written this research paper as a part of our final year engineering. We have recently completed our final year engineering from the college, and our guide for the same was Professor Urmila Kalchetti. So we four are the authors for the paper. So we started working on PortFast audio-based summarization by referring to a research paper which is published in IEEE. And as we proceeded, we found out a few drawbacks, and we overcome those drawbacks and proposed a new model. So now I will start with the presentation and explain our proposed model. So these are the objectives for our today's session. So starting with the introduction, a podcast is an episodic series of spoken words or digital audio files that a user can listen for entertainment purpose or to gain knowledge. So in recent years, podcasts have increased a lot, and now even in India, a lot of creators have started creating podcasts apart from YouTube and Instagram. So podcasts also have a scope of being a platform for curation of content. But the problem with the podcast is that the podcast is very large, and hence for the curators, it is very difficult to decide whether to invest their time in listening to the podcast or not. A text summarization can help understand the contents of the podcast, but the presentation style of narrator and the overall content still lies a problem. So we proposed a model for audio-based summarization, which will help in podcast curation. So as I mentioned in the introduction, that the presentation style of narrator and the overall content cannot be found out by using the text summarization. So that gives rise to extractive audio summarization. So basically summarization is of two types: extractive summarization and abstractive summarization. So when we talk about extractive summarization, the sentences are taken directly from the script. And when we talk about abstractive summarization, based on machine learning techniques and like grammatically new sentences are generated which are equivalent to the summary. So extractive summarization can be used to create an audio-based summary where the sentences are fetched directly from the podcast text transcript, and then those are taken, those timestamps are used, or those indexes are used to fetch those files and create a summary. So current research related to our domain was, there was a very limited research, and the main idea of the research was that the podcast was converted to text using speech-to-text models, and along with the speech-to-text model, the timestamp of each and every word was calculated, and then this timestamp was used to figure out the sentences. So like most of the APIs like Google speech-to-text API, Amazon, AWS, and then even IBM Watson, what they do is they, whatever is the podcast, they will like convert each and every word, its starting timestamp and ending timestamp, and in this way a transcript will be generated. But the drawback in this current research model was that timestamp based APIs and models were not freely available, and the cost of those models was very high, and it was very difficult for beginners, and for scalability, people would have had to pay a lot of money. So instead of that, we came up with another proposed model. So our proposed model removes the dependency of timestamp, and it generates summary without using timestamp. So non-timestamp based APIs can also be used to generate the summary. So this is our proposed model. So a podcast audio file is given, and it is split on audio sentence. So an audio file is using Python libraries is split into audio sentences to form chunk files. So these are the n chunk files based on silences. Then an automatic speech-to-text API or a model is used. For our research, we use the WASP open source model. Once we do that, each and every file is converted into transcript. So WASP model itself is a timestamp based model, but the problem with this model is that the timestamps are not at all accurate. For instance, for a 60-minute podcast, the timestamps of the last word can be for 70 minutes, which itself shows that the timestamps were randomly generated and had no accuracy. So that's why that was the problem where we decided to implement another approach. So we use the same API, but this time without using the timestamps, we are simply taking these JSON files and processing them to form the sentences. So each and every transcript has a sentence words JSON format. So the JSON format consists of the start, the word, the start timestamp, the end timestamp, and the accuracy. So based on this, we process the text to get the end sentences. Now these end sentences are given to the text summarization model, which will be explained in the next slide. And the output of these are the indexes of the selected sentences, which are used to fetch the audio and generate an audio-based summary. So for text summarization, we wanted to try a machine learning-based approach, but because of lack of proper accurate data set, we decided to shift to a graph-based model. So we use text rank, extractives, and unsupervised text summarization technique. So this is the diagram of the same. So the articles are combined to form the text. So these are the sentences which are combined to form the text, which are again split to form the sentences. Then these are converted into vectors. So vectors are basically the array or vectors in C++. Then a similarity matrix is calculated, and based on the similarity matrix, a graph is used, and then based on the similarity matrix, a graph is generated, and then we use ranking to select the top n sentences which are the highly similar, and these are the summarized. So now the question is that how accurate is the text rank summarization? So for the proof of working, we referred to an IEEE research paper for the same. So over here, they had taken Microsoft MS Word generated and a system generated summary, and they compared it using the ROGUE standards, which is recall oriented understudy of existing value. So these were the results for the text rank summarization. So I will just explain the ROGUE. So ROUGE has various levels, like the level 1 is the overlap of unigrams. So we have the similar words in the system and reference summary. In ROGUE 2, overlap of bigrams, that is pairs of words is selected. And similarly, there are ROGUE L, and then there is a ROGUE W where a weighted LCS based statistics are used. So we just we have only referred to this data as a proof of work. Then based on these values are calculated, which is the recall and precision, and then we calculate the F measure, which is used to calculate these results. So now the implementation. So this was the algorithm. The diagram that I had explained earlier, this was the algorithm, shows the way in which we had implemented the same, that we had converted to chunk files. Then speech to text model was used, and then the JSON files were processed. Then the implementation of the part was that the sentences were processed and a dollar was added, and then a graph was built with the same. And then using text rank summarization algorithm, we had obtained the summary, and the dollar sign was followed by an index of the sentence, and then we had split the summary sentences on dollar sign to obtain the index, and then append those files to obtain the summary. So relative size summaries were obtained. So basically, podcasts can be of any length. So there are various ways of approaching the summary. One way is that we can restrict it to 500 words, or other ways that we can say that 1/10 of the limit. So in these ways, our model was friendly with all the sort of any possibilities. So for implementation of the same, this was the tech stack which we had used. So backend was Django and frontend was Next.js. So Django was used to run all the Python scripts. And Next.js is a library built over React, and it is used for both client and server side features. The database was MongoDB, and the podcast, since they were large in size, Google Cloud Storage was used to store the same. So finally, to conclude, we were able to generate summaries without the dependency of timestamps, and this helped. This also gives rise to future research where transcript generation can also be thought of. So thank you. These were the references. Thank you.
Atharva, am I audible?
Yes, sir.
Atharva,
Yes.
have you done the literature survey of current state of the art? What is existing? Because you have used the text rank algorithm, whatever you have projected, that's fine. But have you gone through the recent work done by some researchers in this domain? Just I'm asking you that while doing the literature.
Yes. So like text rank we used because we were having a lack of data set using which we could like create a machine learning based model. Apart from that, we are like just a second. Yeah, the first two and the last, these are the three research papers. So when we started the work, that time only the first two papers were available. But in August 2021, the third research paper was also published, which was in the IEEE journal. So based on these research papers, what we came to know was that they had created their own data set, and they had applied a machine learning based algorithm for summarization over here. But the data set was not available. We only found the paper. That's why we decided to use the text rank algorithm. But all the previous literature work that we read and focused on, the main problem was that timestamps were required to fetch the audio file. And that's why we decided to write our own research paper of a method without timestamps.
Okay, fine. Thank you. Fine. Thank you.
Thank you.
Next is role of co-design in developing an enhanced Moringa-based intervention for rural livelihood opportunities. Vithan Mandesh.
Yeah, good afternoon, sir. Hope I'm audible.
Yeah, you are audible.
Yeah, I'll just bring up my screen.
Yeah, please.
So is my screen visible?
Yes, visible. Make it full screen.
Yeah. So good afternoon, everyone. So I'm Ritan Mandesh. So I'll be presenting the paper Role of Co-Design in Developing an Enhanced Moringa-Based Intervention for Rural Livelihood Opportunities. So just to give you a brief introduction about the work. So this study is in continuation of our previous work, wherein we have previously visited a village named Inpur in the North Indian state of Himachal Pradesh, wherein we performed some rural appraisal, wherein we performed a human-centric study involving different rural PRA tools, which give us an overview of the challenges faced by the villagers. So we identified the challenge of low income generation. So that in turn resulted in the region's dependency on daily wage laborers. So despite the willingness of the women in the village to work and to earn some money, but there weren't enough sources which they could find to earn income apart from the daily wage laborers, which is under the MNREGA. So we proposed the solution based on the large availability of moringa plantations available in the village. We proposed two viable options, which were the moringa oil extraction using the aqueous enzymatic extraction technique, and the other was the powder extraction by using a hammer or roller mill. Sorry. So we thought of bringing in the concept of human-centric design, wherein we would put in the stakeholders as the major point in deciding the solutions. So we then thought of bringing in the co-design technique, wherein the collaborative design would help in arriving at a solution, which would in turn be more efficient and more capable along with the users. So this co-design technique was opted. So this co-design technique was opted, and we organized a workshop kind of thing, wherein our main objective of this workshop was to bring in a solution with all the available tools, and the Moringa interventions which were to be made. So to bring in, so the main objectives was to bring in major user interaction with the women community and to gauge their awareness about the Moringa tools. So we brought in this idea, and then we conducted a workshop there. So along with that, we invited around 35 women to participate. So among the invited participants, 20 were able to participate in the workshop. So this workshop was conducted in a sequential manner, starting with the sequential manner, gauging the awareness, and then so initially the women weren't aware of the. So to gauge, we were mainly determined to check whether the women were already aware of the moringa plantations, and then propose the solution of the moringa interventions like the oil extraction and the powder oil extraction, the powder extractions. So the following co-design tools were used. So the poster cards, mind maps, and the resource maps and the flowchart development was done in a sequential manner, which I'd be explaining. And these are the major tools, and the results that were obtained will be explained on a sequential manner. So the first tool which you would be seeing is the poster cards. So initially, this was done on the first day of workshop. So our main intention was to understand whether the villagers being present there were already aware of the presence of moringa and the powder and the economic capabilities that it had of generating income. So we initially we showed all the food products that were used by the households daily, and they were easily able to identify the products with their sources. But finally, when we showed them the moringa powder and the oil, they were not able to identify them as the sources, and they were also not aware of the moringa plants that were present inside the village. So the moringa plantations were present randomly around the village. So we thought of bringing in bringing in an idea that this moringa could generate income. So the next tool we brought into the workshop was the mind maps. So this mind map technique was one wherein we showed them, we asked them to make a map of moringa. So map on the topic of moringa. So we in turn made them to think about the possibilities that can be done with the moringa. So this in turn made them to realize that there can be powder and oil which can be extracted from moringa. So powder and oil are extracted from moringa. So this in turn brought us into a discussion like the availability of pots. So since the pots weren't available throughout the whole year, we narrowed down our solution. We narrowed down our solution powder extraction, leaving out the aqueous enzymatic oil extraction technique out because of the seasonal availability, and hence we narrowed down our solution to moringa powder extraction. So powder extraction being the major aim, the next main aim was to quantify the amount of raw materials that were available. So the next activity which we performed was mapping the resources of moringa which were present throughout the whole village. So we as a team, we traversed along with the women community who regularly travel through the villages, and we mapped the whole village along with the moringa plantations which were available. So these plantations in green and yellow were two different locations of moringa, and so we in turn got to know about the amount of quantity of land that were available, and also the amount of trees that were present already in the village. So the next main aim was after identifying the amount of resources that were available, was to develop a process flow chart. So this after identifying the amount of raw materials and the scope of generating income, the women were curious about to know like how to extract a powder of it, and how there could be an intervention to earn to make their own livelihoods more efficient. So the next so we developed a process flow chart. So we made them to list the processes, think about and list the processes that were required to make a powder of any raw material. So we then listed the whole process into A2 size sheets, and then we jotted down step by step, and then we explained like what was the first process from the raw material of leaves, and then what was the next process to be followed, and subsequently the final stage of extraction to be a powder. So here while we are explaining these processes, so these the women proposed like since we explained like how drying should be performed and how moisture checks should be done in a machine. So there the women were like they shared their inputs, like they wanted a machine which would allow them to easily dry the leaves and then put in, instead of a complex drying mechanisms wherein which would identify the amount of moisture, and then the microwave drying and all those kind of complex processes they wanted to avoid, and hence we opted for a semi-automated machine wherein the women would wash and dry the leaves on their own. So the whole process flow chart was developed. After developing the whole process flow chart, the next main aim was to first to narrow down between hammer mill and roller mill. These were the two major mechanisms which were identified for grinding the leaves because of the input size. The intermediate pressures were preferred, and hence the roller mill and hammer mill were compared on different parameters such as the powder particles, powder particle size, which can be determined by changing the sieves of the hammer mill, whereas the roller mill does not have the additional perk of changing the sieve size across in a very random way. So in considering the ease of use of a hammer mill and the maintenance cost, we narrowed down our powder extraction technique to a hammer mill. So this hammer mill was selected as the primary area for grinding the leaves. So now and we explained them like hammer mill was one technique of that should be used to grind leaves. They wanted to visualize a particular design. So we made a rough prototype of the locally available prototype of the hammer mill with the locally available materials, wherein we explained like how the hammers would go and hit on the leaves, and then subsequently how the powder will be generated. So this with this they were able to understand like how the process of grinding works in a hammer mill, and then they themselves understand like how to where they should given the input of leaves, and where they should extract the powder, and all those was understood by the women. And after this was the after this was they were able to visualize a particular design where they would be able to wherein they were able to identify, and then more curious about bringing in the solution. So this was the sequence of events that took place, and the co-design tools that were used in bringing up a solution that was more efficient and more capable for the economic upliftment of the women. So these were the different tools, and I would be summarizing it here. So these were the different tools and the outcomes through which outcomes which we had obtained because of using these tools. So because of poster, so initially we started with poster cards, and then with this poster cards we were able to identify their awareness, and then with the mind map we were able to make them realize that there could be an economic upliftment generated out of moringa, and then mapping the resources which in turn resulted in the generating a whole process of flow chart, and then narrowing down to a particular hammer mill design, and then bringing up with the rough prototype, making them aware like this should be the whole process overview. And then our major results. So after obtaining this, we were the next major task was to identify to bring in the semi-automated hammer mill to be in place and perform our market study. So this is our future scope of work which we are planning to perform. So by performing this role of co-design, we were able to bring in a collaborative design which would help the women in enhancing their particular design and economic they should result in more employment, and further also satisfy our UN sustainable goals of 5, 7, and 8, improving the livelihoods and the health benefits of the health of the women community. So that's it from my end. These were the references that we have used, and thank you.
Okay, fine, Ridhan.
Yes, sir.
Done. Thank you.
Yeah, thank you.
Next is insect image semantic segmentation and identification using UNet and Deep Lab P3+. Kunal Boss, paper presenter.
Good afternoon, sir. Am I audible?
Yeah, Kunal, you can share your presentation.
Yes. Wait a second, I'm sharing. Is my screen is visible?
Yes, visible.
Good afternoon, everyone. My name is Kunal Bose, and I have completed my post-graduation from Triple IT Nairpur. And this is first part of my thesis. So this paper is insect image segmentation and identification using UNet and Deep Lab. My guide is Dr. Mitiwari and Dr. Kuldeep Singh Patel, and my co-work partner in this project is Kumar Shivam. So these are the contents of my whole presentation. So let's start with the presentation, where we first have to know what is the image segmentation. Basically, image segmentation is dividing an image into a group of pixels, and on those pixels we have to assign the labels and classify the pixel according to the labels. So as we seen in the figure 1, we have seen that upper side there is original images, and below there are segmented binary segmentation images. So basically here insects are assigned a label and background are assigning the another label to segment out the insect from its background. So basically we are using this mechanism in our thesis in this paper. And also the motive behind this is there is a very major problem in agriculture, that where many crop loss occurs for only two reasons, that is plant disease and insect infestation. So in this paper insect infestation is majorly covered, where we have seen in the picture too that there is one plant of soybean where we have seen that that crop is majorly damaged because of the insect which is
a soybean crop insect known as acorn thickener bug. So the main motivation behind this paper is the rise of image pre-processing in the agriculture industry. We have seen many projects and many uh, models are currently used for the segmentation of plant disease, for the detection of some disease and some detection of insects. So in this paper, we have to identify, detect and segment the insect from its background using the deep learning. So our main research objective will be, first we have to find the research gap on the available data set, that what are the things are not covered in the past data set, and develop a novel data set. And then study and explore various feature extraction methods just like image pre-processing techniques, which will help us to segment it out. And then we have to go for image annotation. Why image annotation is required, I will discuss later. And explore the applicability of deep learning on our data set. So these are my major objectives. So in literature survey, I have seen that there are a lot of paper which start with the moth data set, which have only one class, and it is developed on unconstrained environment. Basically, I can say that there are two type of environment for developing a data set. First is constraint. Constraint environment means when we try to develop a data set by some lab oriented or some human dependent environment, just like we try to remove the background noise, so we have to put an insect on a white sheet and prepare a data set. So those type of data set that are constrained data set. So these are the major difference. And unconstrained data set are those data set which are, we can say, a real time data set, which is covered or captured images of the real field view images. And localization, we can say, when we perform a localization, there are two type of localization. One is bounded box localization, which is basically used for the object detection work, and one is per pixel localization, which is known for image segmentation. So these two are the main and the major objective to develop a new data set and check the flaws, or we can say what are the things which are not covered in past data set. So these are the list of whole data set, where the ninth insect based data set is the base data set which we use and develop our own data set. Basically, the main research gaps are unconstrained environment data set are significantly less, and whatever the image data set are available publicly are basically from internet images, not the images which are captured on field. And highly imbalanced data set means some classes of insects have too many images and some classes have only few images. And most of the unconstrained data set, they have applied bounded box localization. And publicly, there is, I don't find any data set on soybean crop for image segmentation. Also, there are different phases of insect life, just like pupa, adult, and all these
Sir,
things
am I
are.
audible?
Yes, yes.
Okay, thank you.
And sorry, and there are low resolution of images also. So these are the major research gap. On the basis of research gap, the problem statement which we derived for this paperwork is we have to develop a data set which is associated with unconstrained environment and having a per pixel localization, and we have to apply various state of art image segmentation models on that data set. So first part is data set preparation. As I said, we have chosen the ninth point of my literature review, insect-based data set. Basically, this data set is captured, or we can say collect, on the collaboration work between Triple IT Naya Raipur and Indira Gandhi Krishi Vishwavidyalaya Raipur. They collab and have done some project, and on that project, this data set is covered, on which they already applied the object detection work. So from that data set, which we will see the raw images, which is they basically used for the insect detection work. So applying image segmentation directly on those images, I won't think any will be good, because there are a lot of noise, and image segmentation won't work with these huge images. So first work is to image reformatting, where we perform the image selection, removing the noisy images and only taken the important images. After that, cropping the images to ROI, applying the denoising filter. So after that, we have seen one table where we have to remove some images and the final reformatted data set where bug class is having 631 images, red hairy caterpillar having 975 and larva having 952 images. So after that, the major task for the image segmentation is ground truth formation. So basically there are two ways we can prepare a ground truth. First is using image pre-processing techniques, applying different pre-processing technique. If we able to segment out and get the segmented mask, then we easily able to perform the image segmentation. But in our data set, we found that we won't able to apply image preprocessing technique because of three types of error. First is interclass error, where we found that some preprocessing techniques are perfectly good for some images of classes, some images of one classes, but failed in other images of classes. Means if we go for the larva, it perfectly works. But when we go for on caterpillar, it won't able to segment it out. So this is called interclass failure. And next is intraclass failure. We have seen that some preprocessing techniques are able to work fine and it able to segment the insect. But we found that it is only applicable for only few images of a same class and failed on the few images of the same class. So it is known as intra-class failures, and some images are too noisy that we won't able to do anything and we won't able to perform any pre-processing technique to segment it out. So those categories are known as noisy image. So for image segmentation, we have to go for image annotation tool. Basically it is a tool which is used to create binary mask, or we can say a ground truth of an image. So basically the data set which we generate is totally dedicated for image segmentation work on soybean crop. So these are the system configuration and software which we used in our thesis work from Triple ITNR, where we divide my data set into three parts: train set 70%, test set 10 20%, and validation set 10%, where the total image in train set is 1793, in validation test 255, and testing set 510. These are the hyperparameter where we set the learning rate equals to 1 into 10 to the power 4, and optimizer chosen as Adam because it is very good for image segmentation. And we have tried RMS prop, but it creates some pixel misclassification. And we perform batch classification. When we perform the various hyperparameter selection on batch size, we have seen that for lower batch size it performs good but won't able to find the few small image, we can say the few pixels are missed. But we when go for the big batch size, we have found that the accuracy and all the performance metrics goes down. So optimal will be 8. So this is our two model which we on which we implement our data set. First is UNet, basically a standard image segmentation model, and another one is Deep Lab V3 Plus, which is the recent one. So on these two model, we basically applied our data set for image segmentation. We have found that Deep Lab V3 performs better because in image segmentation we have to know the IOs for intersection over union. So we have found that the Deep Lab V3 performs better, and we can see also on image 7 that the prediction of images where we start with original image, then next is ground truth, then next is prediction of Deep Lab V3 plus, and the last one is prediction of UNet. So we have seen that the UNet is won't able to that much clearly predict, or we can say each pixels are not covered on UNet as compared to Deep Lab. So on this data set, Deep Lab performs better, and these are the accuracy and loss plot of both the models. And the final conclusion is we able to develop a large scale data set, which is we called as insect pest data set. It includes 2558 images into three species, and their ground truth respectively. We perform manual annotation because it is better and more accurate than the pre-processing techniques, and ground truth are always considered as 100% correct value. So we have to go for manual work. And for manual work, we have chosen the Photoshop. There are other tools also for that. And we have seen that DeepLab V3 performs better as compared to UNet in terms of IU score, model loss, and we have seen the visualization results of prediction. There are a lot of future scope in this project. We can say an improved image segmentation models can be trained, different life cycle of insects can be covered, GAN model can also be have, and there is another work which I have also done, but that is my future, my research work, that is dividing and the classifying the each insect pest as its respective classes. So that is my future work which I am going to propose, and I have done this. I was just writing paperwork on that, and these are the my references. Thank you, sir.
Sir, may I start now, sir? This is Umesh Mishra.
Yeah, just wait. Let me give some. Okay, just wait. So your work is very nice. You can extend your paper for some journal also, right?
Sir, actually, I am just writing also. I have done the writing, but only revisions are going on.
Achha, okay. One thing I want to ask you that did you try it for different ratio for dataset configuration instead of 70 and 10 and 20?
Yes, basically 70, 10 and 20 are the ideal ones. So I didn't do much on this. And basically people used to only take 10% on test set. I just increased the test set because I want to know that how it will work more on testing when we have more images on test set. That's why I have increased the size of test set.
And regarding hyperparameter, is there this Adam optimizer is optimal, or is there any another option we have for optimizer?
I have tried, but RMS prop is not that much good in this work because on binary segmentation, when we have to identify only insect and background, then Adam works best. But when we go for the multi-class segmentation, where we have to segment insect with its respective class, where we have to label each insect with different pixel value. Here I have assigned all the insect as a single pixel value. In multi-class, which is my future work, I have assigned each the classes of insect as a different pixel value. On those case, RMS prop optimizer works better than Adam.
Okay, fine. Okay, fine. Thank you.
Thank you so much, sir.
Okay. Please stay online. Huh? Yeah, Umesh, you can share.
Thank you, sir. Sir, my research paper is on information and communication technology acceptance among police personnel in Rajasthan. And my supervisors are Dr. V.S. Nirvan and Dr. Tanu Shukla. I will start with the introduction.
Your screen is not visible.
Screen is not visible.
You can just tap on share.
Technological advancements have taken place in every segment of modern life, including the system of modern policing. In fact, modern policing is inconceivable without the use of technology. Technology engagement in law enforcement can bring about many positive changes in the policing system, and it can be used to make procedures, operations, and access to service easy for citizens. An important aspect of technology-enabled governance is the acceptance behavior of technology in policing for effective law and order administration. It is not enough that we have availability of technology. It is also vital that users accept it. There are always reasons behind the usage or rejection of any technology. Technology acceptance can be defined as a behavioral manifestation that can orient a user to either engage with technology in a positive way or in a negative way. The focus of the study would be on the acceptance behavior of information and communication technology by police personnel in Rajasthan state. Information and communication technology usage in governance has been in use for more than 2 decades. The advent of the internet gave rise to a revolution in terms of an increase in the number of end users, sharing and reach. But to a large extent, users were passive consumers. This limitation was breached by Web 2.0. It enabled collaboration and interaction beyond time and space barriers. Basically, it enabled participation by consumers. It provided avenues to make the task of job collaboration and information communication easy, interesting, and user-centric. Numerous initiatives by government and private enterprises enhance the usage of technology in all spheres of governance. Aside from developing the basic infrastructure, the government is also spending awareness programs and also on training programs. The government is concerned regarding taking the technology to as many people as possible. Now I come to literature review. The first 2 decades of the 21st century have witnessed extraordinary growth, not only in terms of technology innovation, but also in technology penetration among the masses and usage. In the policing sphere, Manning in 2003 opined that ICT can be used for communication, movement, transformation, training, and analysis. In its early engagement with technology, the main functions of technology were that of backroom procedure automation. According to Manning, technologies are very complex artifacts and they are used beyond the hard tasks such as surveillance of criminals. ICT can be employed for soft tasks as well, such as monitoring the stress levels of police personnel for their well-being. Higgins in 2015 opined that technology is vital for policing as it would help in work scenarios such as crime mapping, crime analysis, record storing, sharing, and prompt retrieval. There are certain concerns regarding the violation of the privacy of the general public by implementing the use of technology in policing. These concerns focus on an individual's right to privacy and data. The availability of ICT tools on the move through mobile devices and the confluence of internet, World Wide Web, and telecommunication technology has enabled the police officer to use these artifacts in their field work. Now coming to research model, this has been adopted from Venkatesh in 2002. He propounded this model. Basically, determiners lead to intention and then it translates into behavior. So in my research model, there are 6 determiners: performance expectancy, effort expectancy, social influences, self-efficacy, anxiety, and facilitating conditions. These determiners lead to intention of usage behavior, and then comes the actual usage behavior. Now coming to methodology of the research, this study is an ex post facto research. Ex post facto helps explain a phenomenon as it exists at the moment of study. The study has implied UTAT model, that is Unified Theory of Acceptance and Use of Technology, given by Venkatesh. This model suggests a set of constructs that help predict the intention of a user to engage with technology and consequently the actual technology usage behavior. As per ex post facto design, the study was carried out in natural settings of policing in Rajasthan. The research study was a cross-sectional study. The unit of analysis was police personnel individuals. Cross-sectional study is a kind of observational study that analyzes data from a population or a subset of population at a specific point of time. Random systematic sampling was used for respondent selection. 5-point Likert scale based on UTOT theory was used to collect data. Now I will mention the results. Cronbach's alpha has been used to establish the reliability of the survey instrument. For the survey scale, the alpha value is 0.794. Any value above 0.7 for Cronbach's alpha is accepted as a reliable to indicate that the scale has a high degree of internal consistency. Pearson's correlation matrix was also computed. The values in the matrix show that they are above 0.5. It is indicative of strong cohesion and acceptable coupling among the constructs of the measurement tool. Linear regression was used to check the relationship between the independent variables and dependent variables. The regression model suggests that PE, EE, and SI influence the intention of police personnel to use ICT. Basically, it was found that anxiety and basically self-efficacy, they do not have much influence on the actual intent and usage behavior. So broadly, the conclusions are: this study has implied the widely used UTOT theoretical model to discover the user acceptance behavior of ICT by police personnel in Rajasthan. It can be concluded in the current study, performance expectancy, effort expectancy, and social influence have turned out as the strongest determinants of the intention to use ICT in policing. Self-efficacy and anxiety did not play any significant role in creating the intention of the user. The facilitating conditions and a positive intention to use technology eventually lead to the actual usage. It can be inferred from the findings that the usage to improve performance and deliver output is a driver of user engagement with technology. One of the important connotations of this finding is that police personnel are willing to move forward from the legacy procedure of policing. Similarly, the findings indicate that the technology should not be complex. The more complex it is, the less likely the police personnel will use it. Moreover, the immediate social and organizational network of the user, police personnel, is a strong driver, which means that the more the number of police personnel engage with technology, the more the others will be driven to use technology. Thank you, sir.
You have done the recent survey also in this domain?
Yes, sir.
Reliability and all this thing.
Yes, sir.
Okay, fine. Okay, good.
Sir. We included rural police station also and urban also.
Urban, both the scenarios.
Yes, sir. Yes, sir.
Okay, fine. Good.
Thank you, sir.
Next, final. Okay, Sakshita Jaswal. Yeah.
Hello, am I audible, sir?
Yeah, Sakshita, you are audible.
Sure, sir. Is my presentation visible?
Yes.
Yeah. So good morning, sir. My name is Sakshita Jaswal, and I'm here to present my project title, US Traffic Sign Recognition using Partial OCR and Inbuilt Dictionary. So my project is an end-to-end pipeline for automatic detection and recognition of US-based signboards using a novel approach. So it's a part of ADAS, that is Automatic Driving Assistance System, and the various modules of my project are detection and segmentation, anchor generation, optical character recognition, and a prediction module. So I said, right, that my project involves a novel approach. So what's that novel approach? In my project, in the OCR model, instead of sending all the segments that we obtain from our text, we are sending only certain segments based on an anchor generation algorithm. So suppose there's a word school. So it's segmented into 6 characters, SCHOOL. Instead of sending all the segments, we are just sending some of the segments and we are doing the OCR, and this method increases the efficiency of my OCR. So this is the US based traffic signboard, and the advantage that it brings for us is that it has more of text and less of pictograms. So it involves more of OCR models. So it increases our search area basically. So motivation behind the novel approach. So basically we are not sending all the segments. So if we would have sent all the segments to the OCR, computation due to OCR would have increased, but we are only sending some of the characters. And in some of the characters, I would say that it is 40% of the length of the word. And if that length comes to be less than 3, it would be 3. So firstly, computation by OCR is reduced. Secondly, accuracy of prediction is also increased. Suppose OCR's accuracy may vary. So suppose a word is H and it is detected as A. So our accuracy would reduce. But since we are sending only high quality segments to our OCR module, the chances of accuracy increases by a lot. So the main components of my project are detection of text from US signboards, segmentation of detected text, generation of anchor characters from the segmented characters, optical character recognition, and the prediction module. So this is the detection part. Detection is done using an architecture known as textboxes plus plus. Textboxes plus plus is a combination of basically 13 layers from VGG16 module, and 2 fully connected layers of VGG16 are converted to convolutional layers, and then 8 more convolutional layers. It then contains 6 text box layers which are connected to 6 text boxes which are the output. So non-max suppression is applied on that output to merge the result of these 6 to predict the best ones. So as you can see, this is the result for my detection. It is detecting all the words in it, and below we can see the crop text. So the quality of some of our text was very bad. So we tried interpolating them using nearest neighbor interpolation. You can see the interpolated segments, but though it increased the quality of good images, but it drastically decreased the quality of low quality images. So we had to shred this approach. So yeah, as discussed, although interpolation increased our pixel density, which we wanted to increase the quality of our images, but it drastically decreased the quality of low quality images. So we had to shred this approach. Next is the segmentation. Connected component segmentation was used in order to segment the characters. 8 connectivity algorithm was used for segmentation purposes. And you can see the output. Each different color signifies a different segmented character, and the cropping of those segmented characters can be visualized as below. Next is our anchor generation method. So we have detected the word, we have segmented it. Now we are not sending all the characters into our OCR model. We are only sending some segments. So how do we decide these segments? We do it with the help of anchor generation. So we analyze our segments and the kind of noise that could be brought in our segment. So motion blur was mainly the kind of noise that we could expect. So we did what we did was we convolved our image with a Laplacian kernel. So the main concept behind this, or the main assumption behind this, that is if an image is containing high variance, and then there are widespread responses of both edge and non-like edge objects, which is represented of a normal or in focus or sharp image. But if there are low amount of high frequencies, then the image can be considered as blurry. So as I discussed, noise could only be brought about by motion blur, horizontal blur while taking turns when the car is taking a turn, and vertical blur due to speed breakers and all. So these are the examples of motion blur that could be present in our segments, and we need to like filter based on it. So we did an analysis of noiseless image, horizontal blur added image, and vertical blur added image based on 3 parameters. First is image variance, second is image contrast, and third is brightness. As you can see, for noiseless image, the variance was 2786, and when we added horizontal blur in it, its variance decreased, and same for vertical blur also, variance increased. You can see the contrast also decreased, and image brightness also decreased. But since variance was self-evident that it was giving a fair idea that yeah, the image is blurry, so we decided to move with only one feature, that is variance, for our anchor generation method. Now comes the optical character recognition model. A lightweight CNN was used for OCR model. The accuracy of the OCR model obtained was 95%. So the image, the segments that we were getting were sized to an average of 10 cross 10 height and width. And then they were convolved with a 3 cross 3 kernel, which was 64 in number. Then a 3 cross 3 kernel, which were 128 in number. Then a 1 cross 1 kernel, which were 256 in number. And then they were flattened. And then they were classified into 36 categories, 26 alphabets and 10 digits. So this is the accuracy curve of my CNN model used. So regular expression based method. So basically we are sending only certain segments. Our OCR recognizes them and gives the output. So what we are doing is that we take those outputs and the anchor position and generate a regular expression out of them. So suppose there is a word speed and we only pass SPE to our OCR model based on anchor position 0, 1, 2. So this is the regular expression that would be generated. This regular expression is matched against an inbuilt dictionary. In inbuilt dictionary, we are having all the possible words that could be present in US traffic signboards. So if there's a word speed, there won't be a word speeding. So this regular expression is matched against that dictionary. And since we are using dictionary, the time complexity involved is O of 1, which is very efficient. So this is a schematic diagram of the entire prediction model. First, we are accepting the anchor list, and then we are predicting characters corresponding to those anchor positions. We are generating a regular expression, and then we are searching for those irregular expression in our inbuilt dictionary. And then we are outputting the possible word that could be generated out of it. So the conclusion of this model is that it's an end-to-end prediction model, and it has high accuracy mainly because of the time complexity of O of 1 that we are using in our prediction module, the low computation involved in the CNN model, and also the accuracy factor that we are only sending certain segments. The dataset used are as follows: synth text, which contains 8,58,750 synthetic scene image files, mainly to classify text and non-text images, ICDAR 2015, and CAD 74 dataset for training our recognition model. For testing, we had the live dataset from Continental Automotive Components. And I would acknowledge the constant help of my professor, Dr. Vivek Tiwari, who helped me a lot, and the Artificial Intelligence Lab of IIIT NER Raipur. Above all, I'd like to thank my parents for always being a constant support for me. In references, I would like to give a shout out to my first reference, a single shot oriented scene text detector, which mainly helped me in designing my detection algorithm. And lastly, a PyImage search for giving me the idea of blur detection using variance of Laplacian algorithm. Thank you.
So this syntax, this text box plus is an open source framework?
Yeah.
Okay. Second thing, you told about the segmentation, right? That some segment will be, instead of entire text, it will take segment. So did you found any kind of ambiguity problem?
No, sir. As such, we didn't find. And even if we were sending it randomly for good quality images, this was giving high result, because I said, right, if there's a word speed, there won't be a word speeding, speedly. So there's only speed. So there's very less probability that with same anchor positions, there would be a different word. If there's a word exit, there won't be a word exiting. Okay. So it increases our accuracy.
Third thing I want to ask, is there any kind of prototype available for ADAS, this kind of mechanism?
No, we were to prototype this, but COVID happened and we were not able to do it. But yeah, surely we'll do it.
And fourth, you have claimed that this is order of 1 complexity. So due to this is a book dictionary kind of thing, you are saying hashing, order of 1?
Yeah, hash maps. Dictionary data structure was used in Python.
Okay, fine. Thank you. Thank you.
Thanks a lot.
Yeah.
All the presentations are done. So now I would like to invite our session chair for say some few words.
Yeah, just wait. I want to share one thing. Oh, just wait. So overall, I want to say that all papers were good, right? But a few things I observed that so that I have to suggest you few things. So let me show you. Just wait. See, key points which I want to suggest you that whenever if your paper is experimental paper, you just focus on the current state of the art. You identify the research gaps properly. From that, formulate the problem statement. Where see in most of the paper, see few have covered, but most of the paper these were things were missing. So please focus on this thing. That you formulate the problem statement properly. If you have algorithm, your own proposed algorithm or methodology, mention it clearly, right? Evaluation matrix. One of two papers I have found that evaluation matrix were there, but in a lot of paper it was missing. Which are the evaluation matrix, right? It must be presented at a glance in a tabular format. Then finally, you have to compare your result with the existing mechanisms. If your paper is not experimental paper, if it is a survey paper, right, then literature review must be properly in a tabular format, mentioning all the parameters. You have to do the critical assessment of all those parameters. And finally, you have to come up with your insights from those papers. Means what is your outcome from all those things, right? That you have to mention clearly so that it will be helpful to other researchers also, right? And finally, the most of the papers from IoT domain and machine learning domain, right? ICT domain. So I would like to suggest that, see, this is a few next generation topics, right? So next generation network, those who are involved in IoT and ubiquitous computing, for those researchers, you can go for the next generation networking. It is a broad term, right? Which actually discuss about the architectural evolutions and innovations in telecommunications, right? You people can explore the SDN in IoT and this ubiquitous computing also. Those who are dealing with architecture, that can explore the hyperscale network designs. Those who are involved in machine learning and deep learning, they can go for the already some few research scholars have covered this federated learning, transfer learning. I was talking about the graphical neural network also. And interdisciplinary, you can use this technologies and these strategies in your existing work to have some innovation in your existing work, right? So these are the suggestion from my side. If any question, if you have, you can ask, feel free to me. Anything if you want. Okay, Jay, then it is fine.
Yes, sir. All the presentation are done. I sincerely thank our authors for their excellent presentation and have a great contribution in this session, and all our authors for being a part of this international conference. I hope this session was informative enough. We, on behalf of whole team, thank you for the support of this version and the previous sixth version of the conference, and really happy to have you in the eighth version 2023. All the presenters will be getting their digital certificate in 2-3 working days through email. Further, all the papers are already followed with the finger, and the publication will be live within 5 to 6 months. Please cooperate with the team of ICT4SD 2022. I would like to thank our session chair for chairing the session. So this is a token of appreciation on behalf of Global Knowledge Share Foundation and Team ICT4SD. Thank you for your valuable time, sir.
Thank you, sir. Thank you.
Now I request all the presenters for turn on their cameras for quick snapshot to make the memory of virtual conference. Please turn on cameras. We have still 20 seconds. Please turn on cameras. Thank you so much all. Stay safe. Take care.
Thank you, students, also scholars all, and thank you, Jay.
Yes, sir. Thank you so much.
Okay.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.